Okay, so we're going to run over the tools and the approaches that we can use to interpret a digital outcrop model. The software we're using is called Virtual Reality Geological Studio, and it's developed here at the University of Manchester. Um, and it has been designed specifically for dealing with digital outcrop data. So the first thing we're going to do is open our demo project. So you should hopefully have downloaded this and extracted it, so it will come in a zip file which you have to extract before you can open it. Find the VGP file, which is the project file, and it will probably ask you to if you want to reload a particular data set, this color pre-rift scan 1. It will usually ask you to load the last visualized data set, but give you the opportunity to not load it if you want to. So here's our data set. Now this is a point cloud data set from the Gulf of Suez in Egypt. And this data set is collected using a laser scanner, a Regal LMS Z420i. These show the positions where the laser scanner sat when we collected the data. You can see a shadow zone around where the scanner is, and this is the data that's collected from it. It's coloured using photographs from a camera that was mounted on top of the scanner. Now as we zoom in, we can start to see that rather than being a surface, it's actually a set of points, and those points together describe the shape of the surface that's been mapped. Now, though it looks quite good, it can be quite difficult to interpret because you're trying to select points. We can change this point cloud view into a mesh, and you can do that using, in here we would select operations, triangulate, and we'll do from scanner position and use a maximum image length of 1. Now that can take quite a long time to do. You can try it if you want to, but I recommend just cancelling that, and there is already in the project a version of the same data set triangulated. So we just have to wait for that to load. If you click on any of the objects in the data trees, you get some information, and one of those is if it's processing, it will tell you how long it's been processing for and what percentage of a way you are through the process. So if it's taking a long time to load the data, you can see how much it's loaded in by doing that. So let's talk about some ways of navigation. So left mouse button is rotate. Middle mouse button is translate. Right mouse button moves in and out. You can also translate left and right with it. A little bit on the layout of the screen. We have on the left hand side our data tab, which is where our data is stored. So there's things like our point clouds, our meshes, satellite imagery, things like scale bars could also be in there. We have our interpretations tab, so these are the things that we've created in the model, so they can be polylines, structural measurements, and a whole variety of different things. Collections are descriptions, so there might be things like fasces descriptions or grain sizes or lithologies or horizon names. They're things that you use as descriptions, but you can't visualize them directly as an object in the 3D view. So they don't have any checkboxes to switch them on and off with. So if we go back to our data tab, if we open up the mesh, we'll see that it also has some attributes, and in there we have the intensity data. So that's from the laser scanner, how strong the laser pulse was when the laser scanner fires the laser to the outcrop. It records the strength of the pulse that comes back. So it gives you a little bit of information on what the reflectivity is like on the outcrop. We can also look at the individual color channels, so red, green and blue color channels. This highlights very effectively these vertical lines. This is where you've got overlaps in the photographs that were used to colorize this particular data set. So we can switch that off and go back to our normal RGB view. On the right hand side we have our properties tab, which gives us information about the object that we're looking at. So if I select this mesh, it will tell me that we have about 1 million vertices and we have about 2 million triangles, and then there's some things that we can set in our display properties. So one of them is we might want to show some contours on our data. So there's contours shown. We can also have a horizontal grid if we want. So grid in the XY dimension. So we look down on it, you can see it's a grid, and we can change the color of those contours. So we could have red contours, and we could have blue and a green grid. Just gives us a scale on the data that we're looking at. So here we can see that the grids are at 10 meters apart, and the contours are a 5 meter contour. So the red lines are 5 meter contours on the outcrop. So I'm going to switch those off because I think they'll be a little bit distracting on this particular display. And we'll work our way through our different ribbons on the top here. So these are called ribbon bars. And we have a home ribbon bar and interpretations bar. So we start off move, brings us back into what's called move mode. So we can now navigate our way around the model. So if we're in interpretation mode and we're drawing something, we can go back to move mode and cancel the interpretation by selecting that button. We have view from, so a great way if we've got lost in the 3D view, we can reset our view from above, or we can go from look north, from the south, from the east, from the west, and so on. We can do above and below. Navigation mode, you're probably best staying in the default navigation mode, but some of you can try switching into expert mode, which gives you more flexibility in the way in which you can rotate the model in 3D. Target zoom allows you to zoom in on something of interest. So select target zoom, click on something you're particularly interested in the 3D view, and it will zoom you into that point so you can interpret it or look at it in more detail. Game controller and 3D space navigator allow you to navigate your way through the 3D model in a bit more of an interactive way. Project Explorer allows us to change the layout here. We can switch the tabs on and off. A useful one to know is Update Project Explorer, which will just refresh the content of all of the tabs we've got here. Different windows will be pretty much working exclusively with the 3D model window. That's the window that we've got here. Database view we'll look at later on in the module. Then we have some tools for going full screen, working on stereo walls, using orthographic cameras. You're probably not going to mess around with those very much. Record AVI, you can record what's going on the screen directly to a movie file, make copies of the screen, and you can do very high resolution copies of the screen, much bit higher resolution than the screen itself, using this tool. So that's great for doing presentations. Some things here for switching things off in the 3D view. So for example, you can switch the north arrow on and off. Then we have our selection tools that if you want to tidy your data up a bit, so we might want to remove a bit of data from there. We can use rectangle select, and it will select all of the triangles that are in that rectangle, and then we could delete them using the delete tools that are within the operations tab here. We won't go into those at the moment. GNSS allows you to connect your laptop, if you've got this data on a laptop, to a GPS receiver. So if you're working in the field and you've got georeferenced LiDAR data or photogrammetric data, you can navigate around it in real time as you're walking through the field, which helps with interpretation. And then we have some tools for connecting to VR. So connect to a headset and connect to a server if there's multiple people working in the same VR environment. So that's the home ribbon. The one that we're really going to use a lot will be the interpretations ribbon bar. So some of our features that we've seen in the home ribbon are repeated here. So these are very common features that you would use, or common tools that you would use, so we don't have to keep swapping between the two ribbon bars. So let's work our way through the interpretation tools. We have dip azimuth. So if we want to make a measurement, an orientation, so we've got a bed here, we want to work out what orientation it is. I select that tool and I can click 1, 2, 3 points, and it will give me a disk that describes the orientation of that bed. Some of these buttons are what are called split buttons, so the top part and the bottom part are different buttons but are the same tool. That gives you, the top part gives you the default style of the tool, which for this is clicking 3 points, and then if you click the lower part you get some other options. So we could do dip azimuth using endpoints. So I'm going to interpret another bit. I'm in dip azimuth mode at the moment, but if I want to navigate without interpreting, I can do it by holding down the shift key, moving to somewhere that I want to interpret, and then carry on with my interpretation. So just clicking points along here, double click to finish, and there is our new interpretation, the disk representing that orientation, and this is a best fit to all those points that I've just digitized. So there's slight differences between the two approaches. This just uses 3 points, solves the best fit, solves the 3-point problem and works out the orientation. This you can use more than 3 points and it will give you a best fit to those 3 points. Now if you want to make an orientation measurement, you have to make that measurement where there is some 3D shape to the outcrop. So you can see in both of these cases I've selected points that go round a corner. If you try and do this on a straight line, it can't calculate an orientation. So you need some 3D shape. We can map in faults. So we might want to map a fault that runs down here, for example. Double click to finish. And if it's not worked out, so here we've got a bit of a problem with this fault display. It's not mapped correctly, so I can just select it and press delete, and then I can go in there and try again. And you can keep repeating that and deleting it and experimenting with that until you've got an interpretation that fits. So I'll try another one here. There is a fault that runs down here, so it might be a little bit easier to see. If we can't get it to fit properly, it probably means we haven't got enough 3D shape in there. So let's do one last attempt. Usually we could get something out of this one. There we go. That's a little bit better. So it's picked up the shape of that fault, give us an orientation. There is a little bit of a glitch in the graphics on this particular display, hence why it looks a bit funny. But the orientations, the values we get from it are correct. So we can click on it and it will tell you that that fault is dipping at 89 towards 170. So this is dip and dip direction. You can get information from any of the objects that you've interpreted by clicking on them, and you'll see that that information will update in the Properties tab. So there's faults, and then we have polylines. So polylines are where we can draw in our bedding planes. So here we go. I'm going to map in a bed along here. Just click points, double click to finish, and it extrudes that point out from in and out of the outcrop. along what it thinks is the orientation of that bed. So again, it does this best fit to the points. Now that doesn't always work because this is quite a straight line, and also there's some folding in it, so it's difficult to calculate the actual orientation of it. So we could select that line, and I can change the dip here and say instead of 20 degrees it's going to dip at 5, and we can have it projecting in and out of the outcrop. I can then go on and draw other polylines. Double click to finish, and again we could do the same thing. They should appear in our interpretations tab, and they will appear under there. We can classify them by giving them an age, so we can do that by selecting them in the interpretations tab and changing the age. So we could say this is a Oligocene, for example, and then it will split them up by age within the interpretation tree. Or you could go into the collections tab and give it an age for yourself, or give it a description. So let's call it, we could just call it bed 1. And then I would interpret along here. Select that, and in stratigraphy I can make it bed 1. And we could do the same thing again, draw polyline, double click, select it and change it to bed 1. And that way you can start to keep everything nicely classified in the interpretations tab. So that's polylines. We can also do plunges. So if we want to know the orientation of something, a plunge, we can just map it with 2 points and it will calculate the plunge for us. We can do Geobody Mapping, where we might want to map, say, we could map this bed here like this, double click to finish, and it gives us a body extruded in and out of the outcrop that encapsulates that area that we've just drawn around. That's really good if you're working with areas that have got channels preserved in the exposure, and you can map those quite effectively that way. We can do some simple sedimentary logs. So I'll just do a very simple log in here. Let's just run one across here. So I'm going to create log, and I'm just going to select where my beds are, my bed boundaries, double click to finish. We can then double click on the log in the data tab, and it should bring up a 2D window for our log. And we come into our log editor, we right click and do add track, grain size. There's no grain sizes in here yet, so we can add some. So I'm just going to make everything, I'm just going to add some random grain sizes in so we could see it. What you would normally do is this would be information that you have collected in the field doing a sedimentary log. If you look at the digital outcrop model, there's not enough information to get grain size from there, but you could look at weathering profiles, and that might give you an idea of what the grain sizes are like. So we could say that, you know, this bed here, this one might be a coarser sand, and this one could be a, say, a coarse silt, so it's a finer grain, and that's what we've got in there, just based on the weathering profile. We can't actually extract that from the digital outcrop model, but you would use your field observations to fill in the sedimentary log. We can add in extra information in here as well. We could do a bed thickness track, which shows us how the thicknesses of the beds are varying. So in this case, the distance across the log here is proportional to the thickness of the bed. Sometimes we use bed thickness to help analyze what's going on in terms of the processes throughout an interval. So that's our sedimentary log. Go back to interpretations. These are all grayed out because they're not applicable in the log view. If I select the 3D model tab, the window, we go back to our 3D view. We can do some measurements, so measure vertical. It's purely the vertical distance between 2 points, difference in the height. We can have the extended modes, measure horizontal, which measures the map distance, and then we have measure 3D, which measures the three-dimensional distance between 2 points. Virtual scales, we can select put virtual scales onto the model. We can change what those virtual scales are like, so change the height from 5 meters in here. I can make this 10 meters, and instead of 5 segments I can have 10, so 1 meter segments. Or if I think that's too big, I can change it from being a 10 meter scale bar and I can make it a 1 meter scale bar and change the width of it and modify it to suit the size of the model that I'm working on. If you want to do a screen grab or an image on a poster, for example, of a data set like this, you should use 3D scale objects within your model. There's no point putting a 3D measurement in the corner here and saying this scale bar is 10 meters, because it's going to change depending on how far away that point is in the model, because we've got perspective to deal with. So we should put our scale bars all at the same size. So I'm going to switch off that one, and then I'm going to add a new virtual scale in there at a different position in the model. So that's a great way of making sure your model is correctly scaled, or you've got correct scale information within your model. We have waypoints, just GPS positions, and these are used as markers for a whole variety of different processing approaches that we can use. There's multimedia objects, which allows us to attach other information into the model. So this could be photographs, it could be movies, you can link to PowerPoint presentations. Billboarding allows you to add photographs into the model as well. And cross sections they allow you to put a cross section in that you can then interpret on. They're really in development at the moment, so there's a few, not really much point showing that at this moment in time. So that's the basics of how you can go about interpreting up a digital outcrop model using some very simple tools and do a very detailed interpretation. So if you look on Blackboard, you should find 2 or 3 different digital outcrop models that you can use from the UK. You can download those, have a go at interpreting them, and your task is to use these interpretation tools, interpret up the model, and produce a poster that is based on the interpretations that you have made.